Hi, my name is Berenice Baker and I'm the editor of Enter Quantum. I'm here today with Dr. Sonali Mohapatra from the National Quantum Computing Centre. Hi Sonali, welcome.
Hi, Berenice. Lovely to be speaking.
So I wonder if you could just tell me, what is it that the NQCC does?
Yeah, absolutely. So the NQCC is the UK's national lab. It's the National Quantum Computing Centre. So it's a UK centre which aims to tackle the challenge of scaling quantum computers within the UK. We work with various different stakeholders within the quantum computing ecosystem to stimulate the ecosystem and nurture the ecosystem. And this activity ranges from looking after the development of the quantum workforce to the innovation department where I work within, where we look at how we can support industry in the discovery of novel quantum computing use cases and then support that journey to integrate quantum computing within business processes. So that's just a bit in a nutshell of what NQCC does. Apart from that, we also have our technical teams who are building quantum computing systems within the NQCC as well. And you might have also heard about our testbed program where we are also developing various different quantum computing testbeds.
So your role sees you working across many industries. Today you're doing two sessions, one on healthcare and one on aerospace. Now they're obviously very different, but without too many spoilers, can you tell us about how quantum can help in those particular areas?
Yeah, absolutely. And just to put some things into context, maybe. So my role very much. So I work across a portfolio of sectors, looking at how we can support the journey of various different industries as well as various other organizations, understanding where business fits in, where quantum fits in within their business, what opportunities quantum provides, and how can they actually tackle the challenge of scaling that and automating that process within their systems as well. So healthcare and pharmaceuticals is one of the sectors that I lead on. That is one of our priority sectors at the moment. There are massive opportunities in the healthcare sector using quantum, both using just quantum and also in the intersection of quantum with classical technologies, so hybrid quantum classical solutions, as well as intersection of quantum with technologies such as AI. So some of the use cases that we have already supported and funded through our Spark program within NQCC range from the discovery of new drugs. So quantum computers, as you might have heard, are quantum systems. So they're really good at simulating nature, which is, again, has quantum mechanical properties at the very small scale. Drug molecules, medicine, lend themselves very naturally to this because now we have so much data. We get so much data from various different sensors that people wear. We also have very big challenges such as antimicrobial resistance and understanding how we can go towards a sustainable path towards personalized medicine. So in order to simulate molecules, which are, let's say, personalized treatments for a particular person, rather than having it as an average treatment for various different demographics in society. So that's one use case. Other use cases are in the field of privacy and security. So quantum computers obviously are going to be really good at cryptographic. So our current classical cryptographic systems are going to need to be upgraded to be resilient. And not only that, so we also need to be thinking about how quantum can actually help with building up this resiliency in the healthcare system and across various other sectors as well. The other side of this is that healthcare data is obviously, very, very valuable, and we need a lot of that patient data to be able to solve challenges such as how do we come up with treatments for rare diseases. And this is important to tackle because you don't want to be sharing private patient information across different hospitals, for example, or across different researchers because this is sensitive information that needs to be protected. However, there are techniques such as federated machine learning and now quantum-enabled federated machine learning, which allows various different researchers from around the world to be able to upload their data, but then the aggregate analysis, the statistical analysis that happens within it strips away the private sensitive data from being leaked.
Fantastic. And so you've got an academic background very much centred in quantum. So you've studied quantum gravity and theoretical physics. Do people need that kind of degree to get into quantum?
Absolutely not. So I want to be really clear when I say you absolutely do not need so many degrees to be entering the world of quantum. There is a major lack of skills and talents in the quantum workforce as well as the AI workforce. And what we are seeing is that we really need people from very different backgrounds, very diverse backgrounds, and we also have various different roles. So you might not need to be a quantum researcher, for instance. You might need to be an engineer. You might want to be a control systems person. You might need to be someone who is doing project management. You might also need to be someone who is doing communications, because quantum communications and making the public aware and bringing them into that conversation is very important to us, and to ensure that we're not adding to the hype that's around quantum, because yes, quantum can solve many problems, but we are still around 5 to 10 years away from being able to tackle those huge challenges. We are starting to see some form of where the quantum benefits are going to be arising in the next 5 to 10 years right now. So this is very much the time for businesses to come in and start getting their hands dirty and start experimenting and understanding how quantum is going to be beneficial to their business. I also want to say that the end goal of developing this ecosystem is that just as right now we are able to use our PCs and laptops without actually needing to be a computer engineer, we really need to get this out into societal benefit and for people and businesses to be using this without actually needing to have a quantum degree.
Fantastic. And if anyone is watching this today and wants to work with the NQCC to find out how quantum could benefit them, what should they do?
NQCC has a fantastic program known as a Spark program, which was our flagship user engagement program, which was launched in 2022. So under that, we do fund various different kinds of CR&D projects. We also are able to match application engineer expertise to businesses who might be looking to start building up that technical knowledge within their team in quantum. We would also be able to help them develop business cases and get buy-in from executives within the company, for example. So these are just some of the types of things that we have helped businesses with in the past and will continue to be doing so in the future. Anybody looking to get in touch with the NQCC, I'm very happy to receive emails and LinkedIn connections, and of course, if they go to our website, they'll be able to get in touch with the relevant team directly as well.
Fantastic. Sonali, thank you very much. But this has been Verily Baker reporting from the Quantum Computing Summit.